Welcome back. How's my favorite class tonight? All right, so let's take a look at another synthesis problem, only this one is a little bit sassier. So this is going to be fun. This is so much fun. All right, we just learned in the last video that this whole arrow right here is a retrosynthetic arrow. We are going backwards, meaning that this first group right here, this compound is our goal. We need to make this, and we're asked that we can start from any alkane. So it'll be up to us what kind of alkane we want to start with. So let's see if we can kind of start to work our way backwards like we did in the last video, only have just a little bit sassier substrate. So what I'm going to do is turn right around and redraw this over here. And let's start going through our steps and see if we can't just work our way one step backward and make this just a little bit easier. All right, so our first step was to take a look at our functional groups, and then I'm going to add to that. So let's see if we can identify any functional groups in here that is not an alkane. Well, we have only one functional group in there, and if we look at it, that is an ether. Okay. So now this is where you bust out your cheat sheet and your flow chart and you take a look at, have we made ethers at all before? Have we made any ethers? And we have. So we want to get those reactions in our mind. And then the second thing we want to do, especially since we're not given a clear starting material, I want to add to our list. So we start with our functional group. We also start to count our carbons. That way, if we're starting to count our carbons, we're going to get some idea of what's being attached where. Do we need to form some carbon-carbon bonds? How many carbons are we starting with? Since we're able to start with any alkane, then we don't actually need to form carbon-carbon bonds. We can put it together if we choose wisely in our alkane. So on this side of our ether, we've got a nice 2-carbon unit. On this side of our ether, we've got a nice 4-carbon unit. So we're going to want to start with that already in our alkane. All right, so on our last video, we learned how to go just one step backwards. So we're starting with the fact that we have an ether, and we're going to just picture this as a fill-in-the-blanks question, one step backwards. So the beauty of this next test is that we only have 3 general types of reactions. We have radical halogenation, we have substitution, and we have elimination. Now we can usually tell one step backwards just by eliminating some of those possibilities. Is this a radical halogenation? No, it can't be, because we're not actually making an alkyl halide. We either make alkyl bromide or an alkyl chloride, and that is not what our product is. Our product is an ether, so cross that sucker out. All right, what about a substitution? Are you actually substituting something into your substrate that's not just an alkane? Yeah, we are. Just to double check, do we have an elimination? Well, anytime we have an elimination reaction, we end up with some kind of double bond. We do not have a double bond in there. We have an ether. So this is awesome. Cross out 2 out of the 3. So now how do we design an SN reaction in order to make that ether? We need either an SN1 or an SN2. Now we have a set of rules for both of those reactions, and we're going to follow those rules, and in fact they're going to help us figure out, do we want an SN1 or an SN2? So let's erase and clear up some space here. How do we figure out which one we need? Well, the actual ether is what is going to substitute in your substitution reaction. So we can either substitute this part And we could imagine that would be our nucleophile. Or, and hold your seats, this is a fun part. This is so exciting. This is why synthesis tests are so much fun, because there's more than one answer. All right, so what if we picture the ether on this side? And that is our nucleophile. Either one is okay, as long as you follow the rules to that reaction. So just for funsies, let's actually draw them both out as a fill in the blank. All right, so if you were going to do an SN reaction and make this ether, and these are your nucleophiles, let's take a look at that first one. So we always substitute where the electrophile is. So that means whatever is right there. This is the bond that's made when you substitute. So that turns into your electrophile when we go one step backwards. And this is your electrophile. Now, how do we distinguish between SN1 and SN2? We'll look at the electrophile, and we look at the fact that it is primary. So SN1 isn't even an option. It has to be an SN2. Okay, so this is super awesome because let's take a look at it. Now, what does that mean your nucleophile has to be? Well, your nucleophile has to add 2 carbons, 1, 2, and have an oxygen. If it's an SN2, it's got to be negative. So let's put a sodium out front, sodium methoxide. And then what kind of solvent do you want to use? We used DMF on the last one. We can use that again. So look at that. There's your SN2, and now you've just made that ether. Now for fun, this isn't an alkane, so we are not done. We have to make this. All right, so how are we going to make that? That needs to come from an alkane. Ooh. Can I do this? And just treat that with bromine and light? Well, that would be awesome, except if you do that reaction, what are you really going to make? You're going to substitute in the wrong place. So crap. How do we make this, and how do you make your halide here if that's not where it's going to go? You have to use your radical halogenation with chlorine. Remember, chlorine gives you all of those options. So you can, in synthesis for me, you can then use that chloride. So in your synthesis, you're going to make these. You can use this one then in your synthesis. So instead of that bromide, we better start with the chloride. All right, let's look at this second one. What if, so what if we wanted this to be our nucleophile? How would we start that question then? Well, now we would need this whole unit to have the oxygen, and then this side would be the electrophile. So let's erase here real quick. How would we do this? We would need to start with this. Here's those 2 carbons. And then this whole piece, that is your nucleophile, right here, this whole piece has to be negative. And that would be your nucleophile. Remember to count your carbons. And let's add a nice solvent to that, polar aprotic solvent. So if this were a test question, either one of those answers would be fine. But remember, you have to start from any alkane. So you could start with this one and use the chloride, or you can start with this one and use bromine or chlorine. Either one. All right, so this was just another example. This is similar to your homework. So what would this look like in a final synthesis? Remember, we just kind of drew out our strategy there. What would that look like if that was then a nice test question and we wanted to draw that out final? What we could draw is this first one. And then that second piece. And now we just made our product. Okay. Or that would be an awesome answer. Or we could draw the other one. We could use bromine or chlorine for this one. And now our nucleophile would look like that. Okay. So at the end of this process, that is your answer. You could do either one. Either one of those would be totally fine on a homework or an exam question. All right, so definitely try this, and I'll post a couple more. In fact, I think I'm going to probably switch to a practice test. So our next video, I think I'm going to start working my way through a practice test and giving you some test review ideas that way. So definitely don't jump right into that. Try some of these synthesis. Start training your brain to go backwards a little bit, and we'll do a couple